Okay, welcome back to JBTeguihanon, your engineering and chemistry tutorial. So, we're going to, in this video, we're going to do some introduction to the topic called air refrigeration cycle. Okay, air refrigeration cycle. So, we're going to go through the introduction, then unit of refrigeration in this video. Okay, so air refrigeration cycle is actually the air is used as a refrigerant. So air is the use or is a refrigerant. In olden days, air was widely used in a commercial application because its availability is free, right? Free of cost because air does not change its phase. It remains gaseous throughout the cycle. Therefore, heat carrying capacity is very small. Okay, it's very small. Okay, so the air cycle, the air cycle refrigeration system originally designed and installed are now practically obsolete. It's already obsolete, right? Because of their low coefficient of performance and high power requirement. Okay, that's the reason why it's no longer being used, or shall I say obsolete. However, the system continues to be favored for air refrigeration because of the low, okay, it's obsolete but still being used, right? Because of the low of the volume, low weight, and low volume of the equipment. So the air cycle has a compressor, cooler or heat exchanger, expander, and a refrigerator. Okay, it has this what we call components, right? So or elements. We have one compressor, two heat exchanger, three is the expander, four is the refrigerator. Okay, and then we will discuss the unit of refrigeration. This is actually a recap. I have gone through this before and I will repeat it again. Okay, so we have what we call TR, no? Tons of refrigeration is defined as the amount of refrigerating effect RE produced by a uniform melting. Take note of the word uniform melting of 1,000 kilogram of ice from and at, right, from and at 0 degree Celsius in 24 hours. Okay, there is a latent heat of ice which is 335 kilojoule per kilogram. Therefore, 1 tons or 1 TR is equal to 1,000 kilogram of ice. times the latent heat of ice, which is 335 kilojoule per kilogram, over number of hours it's going to be completely melt, 24 hours, right? Times 60, you are converting it from hours to minutes, so you will have kilojoule per minute. Okay, now in practice, 1 TR is actually equal to 3.5 kilowatt. Okay, that is approximately 310 kilojoule per minute. Okay, so when you encounter the word TR, okay, which is the term being used as a unit of the capacity of your refrigerating effect, RE, right? You have an RE here, refrigerating effect. That is actually the capacity of your evaporator. Remember that 1 TR is equivalent to 3.5 kilowatt. Okay, 3.5 kilowatt. So it's just like this. You have a demonstration here. You have a warm air, warm air, sorry. You have 1 tons of ice, and you are going to blow the warm air to 1 tons of ice, and as the result, you will have an output of cool air here, right? You have a cool air on this side. Because of the action of the warm air that produces the cool air, okay, after 24 hours, it's going to be completely melt. Okay, which one? The 1000 kilogram of ice. Okay, and we call it 1 AR. Okay, okay. Now, as we recall, we have the what we call that as I recall, we have the coefficient of performance of refrigerator. Okay, we have the coefficient of performance is written as COP. What is this? This is the ratio of heat extract, extract, extracted in the refrigerator to work done on the refrigerant. It is also known as the theoretical coefficient of performance. So mathematically, this is the formula. COP is equal to Q over W. Okay, so what is Q? The amount of heat extracted in the refrigerator, okay, or the amount of refrigeration produced, or the capacity of the refrigerator divided by the amount of work. Which work? The amount of work done on the refrigerant. Okay, so we have this notes here for per mass. You will have this expression small q. Okay, COP is equal to small q over small w, because it's already expressed in kilo per kilogram mass or per unit mass. And then number 2, you will have a coefficient of performance is the reciprocal of the heat engine. That's obvious. The coefficient of performance is always greater than unity. So it's greater than 1. Okay, COP cannot be smaller than 1. It must be greater than 1. Okay, and here's another note, number 3. The ratio of the COP is the theoretical to the theoretical COP is known as the relative coefficient of performance. Okay, and that is actually equal to actual over theoretical COP. Okay, let's continue. Let's have an example here. Yeah, example 2.1. Find the COP of the refrigerant system or refrigeration system if the work input is W, okay, per kilogram, and the refrigerating effect produced is 160 kilojoule per kilogram. That is actually your Q. So what is given is W and the Q, and the COP is equal to Q over W. That is actually 160 over 80, and the answer is 2. Okay, 2 is greater than 1. 2 is greater than 1, and this is correct. Okay, so this is all for this video. Thanks for watching. Please subscribe. It's JBTeguihanon. Okay, thanks. Bye.